Okay, so Unit 8 is all about area and volume. So we've been talking about area, but it's mainly been with the x-axis, and then it's been exact area or using geometric shapes. So what we're going to do is the area between curves. All right. And so I have a little bit of background here. You're not responsible for all of this notation, just so you know. But the main idea is we might have two curves like F and G, and they don't have to be bound by the x-axis at all. So notice if you look at these three boxes, I can move these regions through the axis, below the axis, above the axis. The area is going to be the same value. So its location is not really relevant. But the idea is if we take those infinitely many thin, and I'm drawing like 3 concrete here, but you got to think of like pieces of paper thin. If you take a bunch of pieces of paper, all like so close together, if we integrate each of those rectangles, then we would be able to find the area. And so we have to think of, well, what really is, and that's why we get this n goes to infinity, infinitely many, sigma means to add up. Well, what is the area of all of those rectangles? Well, you can think of that length, which it's really so tiny, it's almost insignificant. And then the width or the height of the triangle is really going to be this distance, where the y value of f minus the y value of g, and it's going to be the same the entire time. Okay, and so that's going to be the height. And so that's why we say, you know what, the thin rectangle, that value is so tiny and small, it's almost insignificant mathematically, to where I'm really just adding up all of those heights of those rectangles. Okay, and that's the idea. And so that will give us the total. So the only thing you need to make sure of is that if I would draw a height of a rectangle anywhere, is it always going to be the same function minus function? Okay, and so sometimes you might have to split up your intervals or not. Okay, and so that's how it works. Now, when you're finding area, if your rectangles are going up and down, since that means that my limit values are going to go from x equals a to x equals b, okay, because my rectangles are going up and down. There might be times where, especially if I have a function like y squared, let's say I took this, sure, okay, and let's just do this. So if I take and I move my rectangles sideways, I can also do the same idea. So I could have, this would be my a value to my b value, but those are y's, so we'll let them be c and d. And then my rectangle, to get that width, remember we always want a positive width or height of a rectangle. So the bigger number's on the right, so we're going to do right minus the left. Okay, and so this is if your function is basically already given to you in terms of y. There will be functions that you can't isolate for y, and so you need to be aware of this process. We'll use it again in volume, and it doesn't happen that often. Let's say 3% of the time. Okay, and so typically, if you're going from x values and your functions are in terms of x's, you're going to use x's. Okay, so you would use y's if they give you a picture or they give you a function that's already in terms of y. They want you to set it up in terms of y. Okay, and so the same idea. A lot of this is going to be showing your setup. So you might have to find the intersection points of the two functions, and then show your setup and use your calculator to integrate. Okay. Because of time, even on the AP test, they'll just want you to set these up, show it for 1 point, type it into your calculator to get that numerical answer. Remember, you do want 3 decimal answer accuracy. So if your limits are decimals, you need to use all the decimal values on your limits. Okay. Otherwise, your answer won't be to 3 decimal place accuracy. You can chop off your 3 decimals or round. They don't care. So I don't care. All right, so let's just show what the work kind of needs to look like. So it says find the area of the region bounded by this parabola. So I know this parabola opens down and then this line. If you want, you can use your graphing calculator to sketch. Sometimes it's just easier to do all of that work by hand. It's really a choice. We are going to have to type these in to integrate them anyway, so it's not terrible. And most of these functions are going to be pretty simple, that the function graphing is not going to be the factor that's holding you back. So 6 minus x squared, so we'll go up here to 6. I know that's not a great graph, but that's okay. And then we've got y equals x. And so what it says is you want to find the area of the region that's bounded. And so they don't always tell you which region they're talking about. But if you have a graph, then you'll see something needs to be enclosed. And so they're really referring to this region. So I know this, which I don't know where that is, that's going to be my A limit. And wherever this happens, that's going to be my B limit. And I always just draw one little skinny rectangle here. Okay, that's not so skinny, and it's always top minus bottom. So top, and I do write this as a reminder. I always put a dx, let's leave a space here because I write really big, a dx at the end because that tells me this is a derivative. I am integrating with respect to x, and so I do like to have that. Just get used to it. So my top function is 6 minus x squared. Minus my bottom function is x. If this was more than one term, obviously I would use parentheses. Now, because of the notation, I don't really need a parenthesis here. If it bothers you, you can draw one in, but this notation is understood that all of those terms are together. Okay? So I do need to find my limits. It really is just a choice. If you want to find the limits by hand, let's say you weren't given a calculator, I would set each of the functions equal to each other. And then we would solve. Because these have all three terms, I'm going to get everything to one side. So I'm going to subtract 6 and add x squared. So I get 0 equals x squared, put them in order, plus x minus 6. This factors into x plus 3, x minus 2. So x plus 3 equals 0, x minus 2 equals 0, and x equals negative 3, and x equals 2. I just like to do this to find limits. I think showing you how to do stuff by hand might help some of you understand what you're doing, I guess. But you're welcome to use a calculator for this. Be knowledgeable, though, in case you did have to do this by hand. So negative 3 is my lower limit, because this would be at negative 3, and positive 2 is my upper limit. All right, so once I have this set up, you really are just going to plug that in. You could integrate this by hand, but honestly, there's no reason to. It just takes time away from everything, honestly. This could be free response or multiple choice. I still don't have my software. It was supposed to be here by now. So remember, on your graphing calculator, we're going to go to second calc, and we're going to hit number 7, the integral. I know you can't see this. My lower limit is negative 3. So remember, you can type that in. Our upper limit is 2. So I'm typing that in right now. And wait a second. It didn't do it right. I'm looking at my calculator. Okay, so I just learned, because I have a new, my old calculator actually uses F and int. And so up until now, I've been using a new calculator that has it programmed differently, and we've been able to use our graph. But let me go ahead and find a picture of a graphing calculator, since I don't have my software right now. When we go, okay, so I have one of these color ones. So in order to do the numerical integrals, when it's bound, it does it if it's bound by the x-axis. So that's why we've been able to do them up until now, okay? But in order to do them when they're bound by each other, we're going to have to hit this math button, okay? So you're going to hit math, and then you're going to go down to number 9. And it's called, I call it FNInt, so it's function integral. So I'm going to write this on my thing. So you're going to go to the math button. And this, remember, is only when it's between two curves. We will have to do this for volume as well. You're going to do number 9, which is FNInt. Okay, and then you'll hit enter. And it's already in, I call it pretty print because it used to not be this way, just so you know. So we used to have to put in commas and a bunch of stuff. So we're going to put in -3. And what's kind of nice is you don't need the graph for this. So -3 to 2. And it looks just like this. And so you're going to type that in. So we've got 6 minus x squared minus x. I will have to remake this video when I get my software. And then you do have to put in the dx, okay? So that also is a good reminder for you to write it on your paper and then just hit enter. So I got 20.833 and I just chopped mine off, okay? So I know you can't see it, but if you're using the graph to do these intervals, it's going to give you like 18 1/3, but it'll show you the region and it's not this region, okay? So that should be your clue that it's off. That's how I knew. All right, so let's do number 2. It's number 2. This graph is probably a little more complicated because we have all these cubes and squares. So if you want to get an idea, you're welcome to graph it by hand. Not by hand. Well, by hand too, but in a calculator. So 2x to the 3rd. I'm typing it in. Minus x squared minus 14x. And you can use Desmos for this too if it's faster for you. 4x minus x squared. All right, so I'm trying to graph it on the video so you can see. So I know it's a cubic. All right, and then I know this one. On mine, it looks like this. So I'm trying to get the best picture I can. Okay, and so my window, obviously, it continues. And so I would assume that this is going to keep going and this is going to keep going down. And so I've got this to this is going to be one region. And then we've also got this region. Okay. And so what you notice is that my top over here of the yellow is black and pink, but the green region, it's pink and black. So we can't just integrate with one integral. So we're going to have to split this up. If you want to find out where they intersect, we can set these equal to each other by hand. So, oops, let's do it in a color. To find limits. So I've got 2x cubed minus x squared minus 14x equals 4x minus x squared. I'm going to move everything to the left. So I'm going to add x squared, so those cancel out. I'm going to subtract 4x. So factor out a 2x. So 2x, x minus 3, x plus 3, these are perfect squares. So x equals 0, x equals 3, x equals -3. So -3 for x, it is the x-axis, 0, and this would be a +3. Okay, you can find that with the graphing calculator. So I'm going to set up from -3 to 0. If I draw in one rectangle, like I said, it's the black one, which is the cubic. So I get minus the pink one, which is this. dx. And then we're going to add to that from 0 to 3 and reverse it. So if I draw a rectangle, the top is the pink minus the black is the cubic. Now, what happens if we just do it all together? Well, remember, because these limits are reversed, it's actually going to, in the calculator, it's going to give you a negative integral value, and it's going to take that off this area, okay? So if this is bigger, you'll have a positive value, but it's not the total, okay, if you don't split them up. So I'm going to go ahead. And honestly, when I look at these, because we're just going to split them in. So I'm not going to use my graph. Remember, we're going to go to math, and you can't do these together. I'm just going to keep them separate. So I'm going to go -3 to 0. And then we get 2x cubed. I mean, because honestly, typing these in, that's actually pretty long too. I know it doesn't seem like it, but it is x squared minus 14x, and it's really easy to type in something incorrectly. Minus, I go ahead and distribute. I don't like putting in parentheses, so I'm going to put in minus 4x plus x squared. I don't combine like terms. Like I don't do any extra work that I don't need to do. I'm just going to let the calculator do it all. Because why not? All right, so I got 40.5. Which is a nice value. And then I'm going to do math again, go to 9, and we're going to go from 0 to 3. They might be symmetrical. Honestly, it's hard telling. I could go ahead and do the same interval and just change my limits from 3 to 0, and it would give me a positive. But what do we get? 4x minus x squared minus, once again, I distribute that, so 2x cubed plus x squared, I don't combine, and then plus 14x. And then dx, oh, they are. So we get 81. It is square units. We don't need a label though. Okay. And so that would be the area that's bound. Now, is it a coincidence that they're symmetrical? It really is, but it's based on the functions. Okay. So I would not take that for granted or just assume. All right, number 3, they give us a picture, but I still think it's a little confusing, or at least I've had students confused in the past. So this says, find the area of the region bounded by the graphs of 12 minus x squared. So I'm going to show that in green, because I like to use colors when students don't know what they're looking at. Y equals -x. And then let's do purple. Y equals 4x. And so we want the region that's bounded by all green, blue, and purple regions. Okay? All right. And so what we're looking for, let's use orange, kind of, is, well, I know right here, see this region right here? It's bounded by green, purple, and blue. So I'm looking at this. This region, well, that's green, blue, and purple. So right there. And then this region, purple, blue, and green. This is unbounded. That's unbounded, unbounded. So I'm looking at this orange region. Now, the test is you want to draw in some random rectangles. And so I see, oh, it's green minus purple. Well, can I draw that again? I can. I don't have to stop here at that blue line. Green minus purple. And I can do right here green minus purple. But if I go over here, I've got green minus blue. And so now I've changed my rectangle. So you have to figure out, where does it change though? And so I notice it stops right here at 0. So on this side, I'm going to do green minus purple. And on this side, I have to do, for all these rectangles, I'm going to do green minus blue. Okay, so I'm going to have 2 intervals. Why do I say intervals? Integrals of intervals. Intervals of integrals. Ooh, I feel like Dr. Seuss. So on this side, my green was the parabola. So top minus the bottom, which is the purple, 4x. And on this side, when I know I'm going to start at 0, I've got the green, which is 12 minus x squared, minus the blue, which is negative x. So I would make those a plus. Okay, so we need to find out where these are. So I need to find out where these intersect. It's probably just quick for me to do these by hand. It's really just a choice. So I'm going to really look at where the green is equal to the purple, which is 4x. And so I'm going to add x squared, subtract 12, factor. So set equal to 0, so negative 6 and 2. So I know this is at negative 6, which it did look like that. And the 2, remember, that's the purple. So this is at 2, okay? But I need to know this. It looks like 4, but just to make sure, we're going to set the green, and it's equal to the blue, which that's negative x. So add x squared, subtract 12. So x minus 4, x plus 3. So x equals 4 and negative 3. So I know that was negative 3, and this one is at 4. Okay, and so we're going to type these in. So go to math, number 9. I'm going from negative 6 to 0 of 12 minus x squared minus 4x dx. Ooh, that's nice. I wasn't expecting that. Isn't that really odd? Like that curved region has an area of 72. Like, I just think that's bizarre how math works. Number 9. So we go from 0 to 4. I know, you can tell I'm a math teacher. So 12 minus x squared plus x dx. There we go. That's what I would expect. I mean, it is even amazing. Now, I always go to more in case that other one was a decimal, because you need your answer to be to 3. So they don't look after that. So if we add those together, I'm going to get 106.666. You really can chop it off. I always do. I never round. And that would be our area. All right. I think this is my last one. Yep. Okay. So find the region bounded by these curves. Now, we can get y alone, except remember, when you take a square root, you get plus and minus. Okay, and so if the equation's given to you in terms of y, I want you to get more comfortable with it because it will be easier to integrate. Okay, and so let's review some of the graphing rules. So when you have y squared, it's going to open to the left or to the right. The way it works is if y is negative, it's going to open to the left. If y squared is positive, it's going to open to the right. Okay? So I know it's 3 minus y squared. That 3 is really a shift, but all I do is I just kind of, I'm not really concerned with accuracy. this line, I do kind of cheat, and I'm going to subtract 1. So x minus 1 equals y. Now that line, I hope you can do this in your sleep. So I'm going to go down 1, and I know it's got a positive slope, and so I'm looking at this. Okay, and so that's why I don't really care about accuracy. I don't make a table of values. It's not that important. So we're looking at this bounded region. And so you do have an option. If you want to do your triangles up and down, I can draw rectangles and it's purple minus red, but here it's red minus red. See how that's bizarre? So that's why if I draw my rectangle sideways, no matter where I am, remember it's going to be right minus left. The right is always touching the red and the left is always touching the purple on the whole region. And so that's why it makes sense. And so we're stacking all of these rectangles on top of each other. So I need to know the lowest y value and the upper y value. So remember, we get those by setting them equal. So add y squared, subtract 3, factor, okay, so that's at 1 and that's at -2. So we are going to go from -2 to 1. And the right is the parabola. So 3 minus y squared. The left is that line. Remember, use the one that's in terms of y though. So y plus 1 dy. Now, when you go to type this in your calculator, don't use y. Remember, we're still going to use the x as the dummy variable in the graphing calculator. So we're going to go to math. Plus that x button is just a lot easier. So go to 9. We're going to go from -2 to 1. Ooh, I know this video is getting long. Sorry, everybody. So 3 minus x squared. And then minus x minus 1. Like I said, I'll distribute, but I won't combine. I just don't want to. And so I got 4.5. That's the area. All right. So go ahead and give your problems a try. I have 3 there. Notice that one with the y. I have trig. That's just the interval for your window, okay? So there'll be a bound region from 0 to pi that you're going to be looking for. And then this question is kind of a funky one. So I purposely didn't do it. I want you to try it, and if you're stuck, just put a question mark and I will explain. I'll even send a video to you on how to do it. But I thought this was interesting. And then one of these is from the 2008 release exam, and then another one. This really has to do with how you type it in. So that's kind of the challenge. Okay. So try those 6 problems. That should be a good start and a good intro to the next section. Okay. So you definitely need to do this section before we do the next section. All right. Good luck.